Hello everyone, welcome to my channel iSmile Academy. This particular session will concentrate on the instructions of 8085. So I have already covered this instructions in my previous video, but this one actually I am covering with respect to the categories. So 8085 instructions can be classified into various categories. One of the category which we will cover today is the data transfer group. As we can see here, there are various data transfer instructions: MOV, MVI, then LXI, LDA, STA, LHLD, SHLD, LDX, STX, and exchange, XCHG. So this 10 instruction will cover in this particular session. Apart from this, we also use halt instruction because when we write the code, we need to stop the program. So for that purpose, we'll use the halt instruction. So let us start with this. The very simplest one, that is we start with this MVI instruction. Okay, so we just click on this MVI instruction. When we click on MVI instruction, as we can see, the registers which are highlighted A, B, C, D, E, H, L, and this M is the memory location. So we can so this says that MVI, we can write the instruction MVI A, MVI B, MVI C, MVI D, MVI E, and so on. Okay, so let us try with MVI A. Now we have to enter the data, so this hex digits. By using this hex digits, we can actually enter the data. So let us take 10. Okay, so I have written the code MVI A10. Okay, so then let us try one more, MVI B. Okay, I will write this 20. Okay, so all this are possible with MVI. We can even try MVI C, MVI D, MVI E, MVI H, MVI L, and MVI M. We'll just try this too. Okay, then let us try one more instruction, that is move MOV. Okay, I write move MOV. Okay, and CA. Okay, so this instruction, when we actually write it, it is move C comma A. In this simulator, it is just C and then space A, so we can actually interpret as move C comma A. Then next instruction, move, let us take D B. Okay, and then finally the halt instruction. So this we have written the instructions, and here this whatever this 3 1 0 0 6, they are actually the hex code. Okay, so this is we will try this. Let us see what happens when we execute this instruction one by one. Now we execute it. We execute this in step mode. Okay, so the first step, what we see is with MVI A10, 10 gets stored in register A, and in the second instruction MVI B20, so 20 gets stored in register B. So you can see this column is for register A, this is for B, C, and all the other registers. Now with the next instruction, move C comma A, so the data from A is copied to register C. So as we can see, C also contains 10, and the data which was already there in 10, it remains as it is in register A. Then with move D comma B, whatever data is in register B is copied to register D, and B, the contents of B are not changed, and then the halt instruction is executed, so it halts the program. So this was regarding the what we say, this instruction. Okay, the move and MVI instruction. Now let us see some more instructions. Okay, so we have covered this one. Now let us go for LXI instruction. So I just click on LXI. When I click on LXI, this 4 registers, they get highlighted, this B, H, D, and SP. So these are the only instructions with respect to LXI. Okay, so if I write LXI B, I have to enter the 16-bit data. So let me enter 10 20, and then LXI D. With LXI D, suppose I type 3040. So here I am getting whatever I am typing here. I am just selecting here. Then finally let us take LXI H. LXI, let us take 4050. Okay, so this is what we are getting here. Then we type the instruction HLD. Okay, so we'll execute this instruction one by one. So first is LXI B. Now whenever this LXI B is for the full form of LXI is load register pair. So in case of 8085, there are 3 register pair, B, C, D, E, and HL. So with LXI B, let us execute. With LXI B 1020, so B and C, they get loaded with 10 and 20 respectively. So B has 10, C has 20, as whatever data is here. With LXI D 3040, 30 gets stored in register D and 40 in register E. And with the next one, LXI H 4050, 40 gets stored in register H and 50 in register L. And then finally we have the halt instruction. So this is with respect to the LXI instruction. Now let us see some more instructions. Okay, now let us see LDA STA instruction. Okay, now LDA I'll just type LDA, and here 80450. Okay, and then let me type this STA. I'll just type 8060. Okay, and then halt instruction. So this we will consider together. Now this LDA instruction is with respect to the memory location. What is the full form of LDA? LDA means load accumulator direct, and STA is store accumulator direct. So before executing this code, we must enter some data in 8040. So here we have the data grid. Okay, I will just type the memory location 8050, and I will load some data here. Let us take the data as 11. Okay, so I've typed the data. I've just entered the data 8040 11 11 at 8050. Okay, let us see what happens with this when we execute this code. So with the first step, as we can see, with LDA 8050, what happens is that the data which is at 8050, what is at 8050? 11. So 11, it gets stored in register A. So what this LDA instruction does? LDA instruction, it copies the data from 8050 to register A. Okay, so that is what we are getting. So at 8011 gets copied in register A from 8050. Okay, now let us see what happens after STA when we execute the instruction STA. Okay, with STA, what happens is that the data which is in memory, which is in register A, that is 11, it gets stored at memory location 8060. So STA 8060, what it does, it stores the data from register A to memory location 8060. Okay, so LDA and STA, LDA loads the data from memory to A, and STA from A to the memory location, the given memory location. Okay, so this is with respect to memory location, and the source and destination here. When we type LDA, the destination is A. Okay, and when STA, the source is A. So from memory location, you can directly get the data into register A only. So this is regarding the STA. This both the instructions, they are of 3 bytes. Okay, now let's see some more instructions with respect to this. So okay, now LDST is finished. Now let us see this LDAX and STAX, because we have already done STA and LDA. What happens with LDAX and STAX? Let us see this. Okay, so okay, so I'll just for this understanding LDAX and STX, we need to use this instruction LXI. We need to initialize the memory pointer. So I'll just write LXI B. Okay, 8040. Okay, then LXI D. Okay, 8050. Okay, and then I will just type the instruction LDAX B, and then LDAX D, then STAX. Okay, let me type this B and STX D. Okay, then finally halt instruction. Okay, okay, so now because this instruction the full form of LDAX is load accumulator indirect, and STAX is store accumulator indirect. Okay, so first of all, I need to store some data here. So let me type this 8040. Okay, and let me type the data as 10. I'll just type 10 here, and then I'll type this location 8050. Okay, I'll type some data, like I'll just put it here 20. Okay, so at 8040 I have 10, and 8050 I have loaded 20. Now let us execute this. So with LXI B 8040, B contains 80 and C contains 40. Okay, as we have seen previously. And with LXI D, we have D contains 80 and E contains 50. Okay, now they are also acting, whatever data is in there, it is also acting as a memory pointer for B and C, B and D. Let us see. Now what happens with LDAX? LDAX, okay, what it is doing? It is loading some data in register A, but where this data is in 8040. So this, what does this LDAX B tells us? That load the data from memory location to register A, but which memory location? Which is pointed by B and C. So B and C, they have 8040. So 8040 has data 10. Now 10 gets loaded in register A. Now similarly, if we go to the next LDAX D, what does it say? Load the data from memory location to register A, which memory location which is pointed by D and E. Now D and E, they are pointing to 805. So D and E contain 8050 and 8050 contains 20. So this 20, as we can see, it gets loaded in register A. So this is 2. Okay. Now what happens with STAXB? Okay. Now STAX is opposite of LDAX. So STAX will store the data in register A to memory location which is pointed by BC. Okay. So B and C, they contain 8040 and the data which is in A is 20. So 20, as you can see, it gets the data previously was 10, now 20 is getting stored here. Okay. Now let us see what happens with the next step. With STAXD, okay, the data from register A, it gets stored to the memory location pointed by DE, but it was already 20, it remains 20 to 20 itself. Okay. Now with respect to LDX, there are only 2 instructions with respect to LDAX. One is LDAXB, other is LDAXD. And STAX also, there are only 2 instructions, STAXB and STAXD. So this was regarding this STAX. Now why it is called as indirect? Because the memory location is not directly provided. Okay, it is indirectly provided to us. Now let us see the other instruction, okay, which we are left to do. Okay, now this 2 are left. Let us do this XCHG. Okay. So before using this XCHG, we need to actually type some instruction. Let us type LXI. I will just type LXID. Okay, 1020. Then let me type LXIH. Okay, I'll take 3040, and then I will take this instruction XCHG and then finally halt. We are essentially studying this XCHG, but we need to type some data in H and DE and HL, therefore we will understand this. So let us now execute this one by one. So step, with first step, as we know, LXI D 1020, so 10 will get stored in register D and 20 in E. With the next step, LXI H 3040, so 30 stores in register H and 40 in register L. Now let us see what happens with XCHG. Now with XCHG, what happened is what we got in D was 30, what we get in D is 30 and E is 40, and in H we have 10 and L 20. So what happened is that the data from DE is interchanged with HL. So previously DE was 1020 and HL was, as you can see in this particular third row, the DE contained 1020 and HL contained 3040. After this XCHG, DE contains 3040 and HL contains 1020. So this contents, they are, so D is interchanged with H and E with L. Okay, so this XCHG instruction, it exchanges the contents, okay, or interchanges the contents of HL with DE. So this is how, this is only for HL and DE, not for any other register pair. Okay, now let us see the last one. Okay, so I'll just clear this content. Okay, then get the code keypad. Now we have to study this instruction LHLD and SHLD. So before using this, we need to store some data. Let me store, or let me write this instruction. So LHLD, it is, let us take this as 8040. Okay, and then SHLD as 8050. Okay, 8050. Okay, and then halt. Okay, now let me store some data at 8040. So 8040, I'll store the data as suppose 10. Okay, and then here I'll take the data as 20 at 8040 and 8041. Okay, now by default it also gives 8042. We are not interested in 8042, it is giving this, so 00. So we are only interested in 8040 and 8041. Let us see what happens. So with the first step, LHLD 8040, okay, what happened is that whatever data is at 8040, now 8040, it contained 10, so this 10 gets stored in register L, and the next data byte, that is 20, which is at 8041, it gets stored in register H. Okay, so LHLD means what? Load HL register pair with the data from 8040 and 8041. Okay, so LHLD 8040, what it does is that data from this 8040 is copied to register L, and the next memory location, that is 8040, data from 8041, sorry, is copied to register H. Okay, so this is what L contains 10 because 8040 contains 10, and H contains 20 because 8041 contains 20. Okay, now what will happen with SHLD 8050? Let us see. Now with SHLD 8050, what we see is that at 8050, okay, we are storing the, now in this case we are store HL, this is store HL register, store HL to memory location 8050. So in this case the data from L is copied to 8050 and the data from H is copied to the next memory location. Okay, so this is storing the data to 8050 and 8051. Okay, so this is how this particular instructions works. So we have already covered all these instructions from move to this one, exchange. Okay, so that's all for this particular session. Thanks for watching. We'll be covering the arithmetic and logic group in the next videos.